So in this video we're going to have a look at those stratigraphic diagrams that is part of the practical workbook and part of the next assignment. So stratigraphy is all about having a look at the sequence of geology in the landscape. And the really cool thing about looking at stratigraphy is that you can tell the geological history over millions, sometimes hundreds of millions of years. So we can have a look at a diagram like this, where quite a complex one we saw in the lecture. If you know something about stratigraphy and how to interpret the geological layers, you can then provide the geological history and tell a bit of a story. We'll start with a more simplified diagram. We'll start with this one here, which is a bit similar to the ones that you have in your practical workbook, and we'll see if we can interpret this geological history and in the process give you some tips on how to do the ones that you have to do. Okay, so let's put it down and let's work through it. Okay, so here we have our final stratigraphic diagram that you're going to be asked to interpret. Tell us about its geological history. Well, in order to do that you have to start at the beginning. So let's go back in time. Let's rewind the clock, simplify the diagram so that we just have 4 layers of sedimentary rock. And we can put labels on them. Let's go D, C, B and A. So we have 4 layers. Now if we were just to interpret that geological history, we would just say layers went in this order: D, C, B and A. You don't have to say anything else. We assume that everybody knows that there was sedimentation and then lithification. You can say that if you like, but just to simplify it, we just say D, C, B and A. Or you will say whatever those rock types are that are printed on those diagrams. Alright, but then something happened. We had a period of folding. So let's fold these beds. Let's squeeze them from the outside, simulating large tectonic forces, and we now have a fold. And you can see 2 new beds have been revealed that were existing underneath. They've just been revealed in our little cross section here. So now we have 6 beds, and we can label them F and E. So now we can see the bottom 2 beds. The full geological history would be F, E, D, C, B and A plus the fold. So we've introduced a geological process. So that's the full geological history. You have to include the processes that are there. Alright, then something else happened. We had a fault occur, a large earthquake, and this left-hand side was displaced downward. So that's an additional process there. So the full geological history then is F, E, D, C, B and A. Then folding, then faulting with the left-hand side thrown downwards. So it's important to see the effect of the fault. So you can see here now that on the left-hand side we've lost the bottom beds, haven't we? We can't see F, and we can't really see, can't see F, and we really can't see E. So it's important to, when you look at a fault, to try and match up the beds on either side of the fault, and that will help you to interpret the geological history. So on the right hand side we can still see F, we can still see E, and then we can see D, and then you can see D are here and D is here, and then we can see C and C, B and B, A and A. Alright, so just keep that in mind that when you're looking at a fault, to match up those beds, because you may not see the beds on both sides of the fault because one's been displaced out of your vision. Alright, so there we have our fault. But then something else has happened, a new process has happened. This has been exposed, and so if it's been exposed to the weather, then the process of weathering, erosion and transportation can occur, and so this top layer has been, or the top part of the diagram has been subjected to erosion, and erosion happens horizontally, and you can see that it's taken off the top of the hill, revealing just a very flat surface again. So on one side we've completely lost the layer A, and so the full geological history then would still be layer F, E, D, C, B, and A. We now know that geological history. Then folding, then faulting, and then erosion. See how it works? Okay, so you have to include both the deposition of the layers as well as the processes. And then to get to our final diagram that we saw at the start, there's been deposition of another sedimentary layer, and we'll call that X, just for the hell of it. And it's been deposited flat onto that horizontal surface that erosion caused. And so we now know that that flat layer seems to be occurring on a folded substrata, and so we call that line, do you remember what we call it? We call it an angular unconformity. So if we see this diagram, then we know that there must have been a period of significant erosion to have removed what should have been a hill, essentially. It's also removed the effect of the fault. Okay, so this one then, the full geological history is F, E, D, C, B, A, folding, faulting, erosion, and then deposition of X. And that's how you write a geological history.